here comes Brittany.
All right, today is the 23rd. All right, today we're going to be doing simplifying polynomials. All right, so what a polynomial is any expression with whole number exponents. And
Whole number exponents.
all right.
Yes.
I have a really random question, but did you have an exponent that was like a decimal? Or?
No, because I'll give you a great example. If you had x to the 1/2 power, it's a square root graph. It's not a polynomial.
No, I mean, I don't mean like polynomial, but could you, not polynomial, but just in general, could you have a, whatever it's called, exponent as a decimal?
Yes.
Okay.
It's a
Yes,
different
you
type
can,
of
but it wouldn't be a
graph.
polynomial.
Yeah,
Yes. Okay, that's what you mean. Yes, you can.
Just in general.
And another thing about polynomials is that it can have any number of terms in the name. Poly is a number, and nomial, many numbers, and nomial is number.
Yep.
Many numbers. And what separates those terms is the exponent. Exponent, underline. So names of polynomials, you have your constants, which have an exponent of 0. And then you have linear, which is x to the 1. Quadratics, x to the 2. Cubics, x to the 3. And then so on and so forth, going up in powers, x to the n.
Quintic, but you won't see those very often. Normally they'll say degree 4, degree 4, degree 5.
Yeah.
Keep going, Brittany.
All right, and then standard form, when you're writing a polynomial, you will write it in the descending order of power, of the powers. And what that means is if you have like x to the 3rd minus 5x to the 5th minus 3x, you would write that as, you would start with your highest power, which is the 5x to the 5th, and then you would have your x to the 3rd, because that's the next number down, minus 3 to the x. So that would be how you write standard form, the descending order. The degree of a polynomial is the highest power. So this one would have the highest power of 5. That would be the degree of the polynomial. The degree of the polynomial also dictates the shape of the graph. We're not doing graphs today, but. And then the leading coefficient is the coefficient that accompanies the highest power. So that would be, the leading coefficient would be -5. All right, and then what we went over in the reading, the 0 or root of a polynomial is f of x equals 0. That's the same thing as setting y equal to 0. Yes. So, example 1. P of x equals -5x squared plus 3x to the 4th plus 10 plus 9x minus 7x cubed. If we were to write this in standard form, we would start with our highest power, and that would be the x to the 4, accompanied by our leading coefficient, 3x to the 4th. The next term down is x cubed minus 7x cubed. Our next one is squared minus 5x squared. And then 9x. And then our constant 10. And the name of the function is p. So, in this case, the degree of the polynomial would be 4, because it's our highest exponent. Our leading coefficient is 3. And now if we were to solve p of 2, we're plugging in 2 for x. So that would be 3 to the 4th minus 7 times 2 to the 3rd minus 5 times 2 squared plus 9 times 2 plus 10. Now if we were to start simplifying that.
Put your calculator, right? Put it in your calculator.
That's what I did.
Yeah.
It was 0.
Yeah, put it in your calculator. Because you're going to make a mistake. You will, right? You'll make a mistake.
So
I'll make a
2
mistake. That's
to
why I put it in
the
my calculator,
4th
right?
is 16. Oh, I should have known that in my brain. And then 16 times 3 is 48. So we have 48 minus 2 cubed is 8 times 7 is 56. 2 squared is 4 times 5 is 20. 9 times 2 is 18. And then we have 10. And then we just simplify.
What do you get for an answer, Brittany?
48, 56 is
We get
8,
0, don't we?
28 plus 18
So what does that tell
plus
us
10
about
is
P of
0.
2?
P 2
It's a root.
0.
Yes.
Yes.
It's a 0 or root, right? If it makes the answer 0, it's a root or 0. Well done. Good go, Brittany.
All right. Now we have this fun one with stuff we've been practicing. P of negative 3i. Let me zoom out a little. It won't let me zoom. Okay.
No, I know it's recording, yeah.
All right, so if we were to start, we would do negative 5, negative 3i to the 4th,
Wait.
minus,
Oh, gotcha. Yeah. Wait, where's the negative 5 to the 4th?
oh wait, 3. Oops, sorry, I was reading the wrong one.
Yeah, that's good.
So 3,
Even Brittany makes mistakes. Doesn't that make us feel better?
that's a 3. Anyways, then minus 7, negative 3i to the 3rd, minus 5, negative 3i to the 2nd, plus 9 times negative 3i, plus 10. This is very long. All right, now if we were to start simplifying this, we have,
I'm gonna move in because I'm gonna be a nice guy, okay? Kai found it. Kai found it. 3 parentheses negative 3i. Oh, we have an I button in our calculator. Look at that. And I never told you, did I?
I have an I button on my
To the
calculator.
fourth, right? Did you guys figure it out already?
That's not okay.
Mr.
Davies, I need to do something.
No.
CRP.
That's what made you do it the hard way.
Can I do it the easy way?
You can do it the easy way, heck yeah.
All right. I mean, I already did all the work yesterday, so if you want to see what it looks like, this is what it looks like, but I'm going to input it into the calculator. So we have 3 times negative 3 I to the fourth minus 7 parentheses negative 3 I to the third minus 5 parentheses negative 3 I. Oh no.
I used the I button on one of the
Minus
17 yesterday, and it gave me a really great answer for
Yeah.
using the I buttons.
5
Doesn't always
parentheses
work.
negative 3 I
Oh, weird.
squared minus, not minus, plus 9 times negative 3 I plus 10.
Awesome. There. Well,
It usually shows me imaginary numbers though.
here it is. That's okay. Here, I got it in Kai's.
I have no idea if I plugged it in correctly, so no.
Well, I know about the answer thing kind of bothers me. That might not be correct, but
The
Brittany did
answer
get it.
is 136 minus 216I. Here, I'll just go through it on this without having to write it all down. So you do this, you simplify your i's. You get 81 times 1, 189 times negative I, 45 times negative 1, and then 27I plus 10.
Nice job.
And then you
Brittany.
simplify it, you put it in a plus bi, you get 136 minus 216I.
Nice job doing it the hard way. Yay, Brittany. That's awesome. Yeah. Very cool.
I already did it, why would I do it again?
Well, yeah, the calculation makes it easier. Okay, so here comes the easy part. You know this. Okay, listen to her.
All right, so this is the exact same thing you've been doing, just with a couple more numbers. So you have your function, you have this, you're solving for the zeros, so you're looking for p of x equals 0, which means you set the entire thing equal to 0.
Already factored,
It is already factored.
right?
And when it's factored and it's equal to 0, you have your 0 equals 3x, 0 equals 2x minus 1, and your 0 equals 3x plus 5. Very easy. You're doing the exact same thing you've been doing. So that's going to be 0. 2x minus 1 is 1/2. 3x plus 5 is negative 5/3. These are the zeros of this function. There are 3 because it is to the third power. You can see there's 1, 2, 3 x's being multiplied together. So it's to the third power, so you have 3 answers. All right, example 3. P of x equals x cubed minus 2x squared minus 8x. This one, you have 0 equals x cubed minus 2x squared minus 8x. Something these all have in common are x. You can factor out an x. And then you have x squared minus 2x minus 8. And then you can factor it again into x, x minus 4, x plus 2. And then you have your 3 mini equations again. And you get 0, positive 4, and negative 2. Those are the zeros for this cubic function. All right.
I have a question too. How do you like create a cubic polynomial that doesn't cost any origin?
Doesn't cost any origin.
Is it origin?
No, we'll to look at those later.
Okay.
Okay, yeah.
Yeah. All right.
They're not easy to factor over.
Yeah, I figured because you have that word.
Do you remember doing by grouping? By grouping?
Oh, yeah.
That's how we do
Oh,
it.
no.
Oh, yeah.
That
Okay, keep going, Brittany.
All right. Example 4, x to the 4th. To the 4th power, we have 4 answers, minus 81. So you can, I did try to do it one way, but it was kind of right, kind of wrong. The way you should do it so that it's easiest, you have your x to the 4th. That can be 2 times 2, so you can have your x squared and your x squared. And then minus 81, that's the square root of 81 is 9. So you have your plus 9 and your minus 9.
Can I stop for a second? So if you were to solve it, bring over the 81 and take the 4th root of 81, you get 3.
Yes.
That's just one answer. There's 4 answers. Keep going, Brittany.
All right, and then you can solve this. It's equal to 0. You solve it, you get x squared equals negative 9. X squared equals 9. This gives you plus or minus 3. And then this, it's the root of negative 9. You get plus or minus 3i.
There's 4 answers. 2 real, 2 imaginary.
And
Nice.
then usually when you're looking at an x to the 4th graph, you can see that there's the 4 intercepts because it looks like this, pretty much. But this one, it looks more like a really wide quadratic.
Okay.
So yeah.
Brittany,